大家好，我是 Coco。今天我们来到明尼苏达州的 Pioneer Midwest， 请店长 Matt 告诉我们滑雪者的体重跟滑雪板之间要如何匹配。
Hi, this is Matt Leaps from Pioneer Midwest, and I'm one of the owners here. And today I'm going to talk about how we fit midline skate skis. And we're a little different than most places. We have a lot of test equipment, as you see. We've got a traditional ski press, and then we also have a machine that I developed with some of my friends, and it helps us test skis. So I will grab a midline ski that I'm going to try to fit for myself, and we'll kind of talk through how we do the fitting for that. So we'll walk over to the skate wall.
Sure.
And
can you show us the traditional way?
Yep.
Versus
Yeah. We'll talk through that for sure too. So, so this is my wall of skate skis, and so the entry-level skis start around maybe $200-300, and race skis will go all the way up to $800-900 a pair, generally. And we still do traditional fitting if we're really busy or if it's an entry-level ski because there's not much variation in the flexes. But traditionally, you would stand on a fit bench and test the pocket of the ski. So I would stand up here. Let me find balance. And I would stand on the ski, and you would have somebody run, and I can test myself. You'd have somebody test the pocket under the foot. And so this is the pocket mark. And if I balance on these guys, you can kind of see the pocket underfoot. And a skate ski, when I go to 1 foot and push down, like this will never close. So you'll get a pocket like this. And so based on how the ski closes is the determination if it fits the skier weight. Well, the problem with this is the skier standing on the skis is variable. So they don't do it the same way. If I'm testing multiple pairs, maybe they pushed a little harder on their foot, or their one leg is longer than the other one. So as an engineer, pretty big into the scientific method, you can limit one variable at a time. So the person standing on the skis, they're variable. So I want to remove them from the equation. With this process at the store, with this different than a traditional fit bench, we use an array of load cells, and this is a machine that I designed and built for my friends. Basically, we're using load cell, and so there's a Wheatstone bridge in here. There's 4 resistors in kind of a diamond shaped pattern. So if you looked at, that's basically the electrical kind of diagram of how it works. But we have 4 wires coming out, and that comes off the bridge. So we have an exercise voltage of 5 volts, and then one of these the resistance across this bridge will change as we apply load. So as we push, the resistance on one resistor changes. Well, we know from Ohm's law that voltage equals amperage times resistance, and if we change resistance because I'm changing tension, then I'm getting a change in voltage out. The problem is that voltage is very, very tiny change. So the thing is we've got to amplify it. So this is the circuit board we designed. And we actually we amplify the signal first so we can see it, and then we run it through an A to D, change it to a digital signal, and then that talks to my Raspberry Pi, which does the communication, and then I take all those that ones and zeros, and I throw it up onto a screen.
So analog and then
digital. Yep. So and so that's how we look at skis, and then I've got 48 of these load cells in a row, and so I will push on the ski at the ball of the foot, which is just behind balance. You can see the change in the camber shape. So this is kind of pressure along the ski. So I'm 160 pounds, we'll say. And this ski, I can see pressure in the tail, pressure in the tip. One of the things I'm most interested is the distribution of aft, so tail pressure, to forebody pressure at 31%. And at half body weight, so we'll go to 80 pounds, we can see that I'm at 38%. And as I apply load, the pressure in the tip reduces. And so skate skis are like a bar of soap in your hands. You have the snow, you have a ski, and then you're on top of that bar of soap. And with good ski form, you apply load and bend the knee and ankle, and you're pressing more on the ski. Well, really good skis, what happens is they actually take pressure out of the tip as a percentage of body weight and dump it in the tail. And that's why it's like a bar soap in your hands. They accelerate.
I'm done.
Everybody likes to use these. Well, there's Corey using the other one, so we built two of these. But here, I can apply load. This is basically a traditional fit bench, except the skier has been removed by a digital, or by a load cell, one giant load cell. We've got a piston full of air, and so we can put the skier body weight. So I'm 160 pounds. Load to 160, and then I can test the ski just like I could over there with the skier standing on the ski, but I don't have to worry about movement, So this is controlled. So I can, and I don't have a foot in the way, so I can use my different metric feeler gauges to mark different pocket lengths, and I can tell a lot on how the ski fits here as well. And we know that if the pocket is too small, it doesn't fit, and if it's too large of a pocket, it won't work. But this just reduces the variable of the skier. But when someone's standing on one foot, they're kind of bouncing around, and I don't want to see that. So this eliminates that variable. So scientific method, change one variable at a time, capture your data, and then make a decision. And we'll sometimes have someone stand on the skis too, because maybe they don't know their weight. So a lot of times I can double check to see if they're lying about how much they weigh, or they just don't know. If I mark pockets here and they stand on the skis, it should be the same. So if pressure looks good here, I mark a pocket here, and then they stand on the ski and it looks the same, then I've got all three things lined up and we're good to go. Cool. If I do this, it looks good, this looks good, then they stand on the ski and it doesn't look good, I was like, are you really 160 pounds? Or are you 180 pounds? So.
Cool. Well, this is the first time I hear somebody mention referring to a ski as a bar soap, because I used to think of a ski as a spring.
And it does that too.
Yeah. So
it's a handmade wooden bridge. So this is what skis are made out of. So this is a core that was cut into shape, and they're dead flat. And then they get cut into shape by this guy. That's how skis are made. There's the cores, that's the wood jig, and that's a bandsaw. It's a wood shop. And then you put skis into a press. So this ski turns into this S-Lab. You can see the core is the same here. And Fisher looks the same, and Rozzy looks the same. Machus is a little different. But you can see that this is a span, so this is a bridge now. So we took a dead flat piece of wood, we pushed a camber into it, and then this is a bridge. And this handmade wooden bridge distributes the skier weight across the snow. So it is a spring, like a bridge would be a spring. You can model a bridge as a spring. As an electrical engineer, we can model springs as capacitors and inductors and all sorts of crazy stuff. And I just was a frustrated athlete a long time ago with an engineering background that said there should be some more data behind what we're doing, instead of just what did I hit? Nothing.
Well,
very soft. I would look at like a Solomon RS10 or an S-Max Carbon. Those are kind of in the $300 price point. They're not $800 like the high end.
So you would recommend Salomon?
Solomon S-Max Carbon is probably our number one selling midline boot. It's just
great. Thanks.
Does everything really well. And then RS8 is $350 with the binding. RS10 is $480, includes the binding. This is kind of where I would look for intermediate. There's another one. This is a little cheaper. This is the Dynamic 2. So these, I believe, are $89. They're just not as light. So when or as stiff. So they're heavier. The nice thing with the Swix ones is they changing to roller ski is very easy because they have the TBS system. So off it pops, you put the roller ski tip on, and you screw it back on. So that's a very easy system. Which is no glue and heat gun needed. You put on a specific roller ski ferrule. So this is the Swix TBS tip. And so there's no snow basket to break, and this is a carbide tip. And this is going to go into asphalt. They don't really work. We use an overseas paint job. I just wanted an inexpensive roller ski, because a lot of the companies that sell roller skis, they're very nice, but they're like $500 a pair. So we do ours for $225 with a binding. So we just want more people roller skiing. And Our brand is Huel,
So-
and they've been
Skate roller ski, skate, and 2 pairs of poles would plus boots would come up to roughly.
yeah. Well, you could get away with 1 pair of poles because you could use the tips.
Yeah,
So-
2 would be
2
safer.
2 is better because
Yeah.
roller skiing beats up the poles pretty good.
Yeah,
so,
exactly.
It's worth $1,300.
$1,300.
Yeah.
And then, of course, there will be accessories and stuff. But
Yeah.
roughly,
Roughly, yep.
yeah, this is
But we can always find closeout options too, like last year's skis, last year's boots. So we sometimes can get people out for a lot less than that.
yeah. And I want to bring my sport tube in because for air travel,
Yes,
that's
yeah.
absolutely necessary.
Necessary.
Yeah,
Yep.
I brought.
We just don't sell them here because REI sells them. They're just a mile down the road. So.
Hi.
The West Wind flag around here somewhere. Where's our tent? Oh, this is kind of the way.
Cool. Yeah, that's good. That's good.
Need some skiing?
Cool.
Thank
Take it
you
away.
everybody for visiting with us. It was great to show you around Pioneer Midwest. We have everything you need to get Nordic skiing, and we're fanatic about it. We love it, and our goal is to just get as many people skiing and having fun skiing as possible. It just will make the world a better place.
Thank you very much, Matt. Hope to talk to you again soon.
Thank you.
最后为大家介绍一下 Pioneer Midwest 的地点。Pioneer Midwest 在明尼阿波利斯机场西北方，开车大约45分钟的地方。我已经将 Pioneer Midwest 的官方网站放在底下，请大家参考。这一集专访让我不但看到了装备与滑雪者重量匹配的方式，更让我了解到电机人是怎么看世界的。最后的附图是老板 Matt 为我们介绍的装备的价格，请大家参考。谢谢大家，我们下次再见。